Okay, this is the first part of MECH 1395 hydraulic lab activity number 4. There's this comparison of these two systems here. Again, very strange system. Look what we have here. We have, in this system, the pump's going to turn on. We have our 1000 psi relief valve, and the pump flow comes out and it gets split through a T, and it goes to both the retract and the extend, or the up and down ports of this vertical cylinder, double-ended, double-acting cylinder. And the question is, what's going to happen when we turn on the pump? And you kind of think, well, the flow wants to go here and it wants to go here. It's going to push on the piston on the top. It's going to push up on the piston from the bottom, and it should all just balance, same pressure everywhere. It shouldn't move at all. And then the second part is, yeah, okay, now the same thing, but with cylinder C1, the horizontal, but more importantly, single-ended cylinder. It has a bigger area, bigger extend area than the retract area. Again, pump flow gets T'd and split, and it goes to both ports. The question is, what are they both going to do? So let's try the simulation. And look, C1 totally extends. C2 didn't move. This pressure, the oil has nowhere to go, so it just all goes through the relief valve at 1000 psi, and this is all static fluid. Pascal's law says the pressure is the same everywhere through this system. You can see that it is. So there's 1000 psi pushing up on this piston and 1000 psi pushing down, and those two pressures create, well, the same force because they're both acting on equal areas. Not true over here. Let's restart and rerun this simulation and watch what happens to cylinder C1 when we turn on the pump. Pump flow goes into the extend port and it comes out the retract port and recycles back in until the cylinder fully extends, and then all the pressures go to 1000. There's no more flow path. It all goes through the relief valve. It's a little surprising, maybe. Why does it extend? Why don't these two pressures balance? They're both not much, but there's more area on this side than this side. There's more square inches for that little bit of pressure to push on this side than on this side. So there's a net force extending the piston, and so it does. Again, no connection to tank. All the pump flow goes into this cylinder. This activity is mostly about something called regeneration. So in this part of the activity, we have just conventional reciprocating cylinder. Flow meter F1 measures the flow going into the directional valve and therefore to the cylinder. Beg your pardon. Flow meter F2 measures the flow coming back to tank. And in this case, we're using this 3-position 4-way tandem neutral position, solenoid operated, spring-centered directional valve, operated by a joystick that energizes these solenoids to shift the valve and make the cylinder move. There's the lever operated valve sort of grayed out because the oil comes in, it goes through it, and it's really just part of the flow path, so it's not really part of the circuit. Its A and B ports aren't connected. So essentially, we can just bang this cylinder back and forth using this directional valve by energizing the coils. And this position makes it extend because the pump flow comes in, follows this tortuous path from P to B into the extend port and extends the cylinder. Flow comes out the retract port, goes in through A and back to tank. In the middle position, you can see the flow all just goes freely through these valves and back to tank. So flow 1, F1, 1 GPM, full pump flow. So is F2. And there's no flow going through the relief valve. We don't have a flow meter, but you can see the valve is closed. I have it set for 600 psi already. I would have done that by deadheading the cylinder. I'll show you that in a moment. So the system pressure is very low. In order to set this pressure, I'm going to adjust the knob. This is sort of the, put this over here. This is sort of the virtual version in the simulation of twiddling the little black knob on the relief valve. And you can see I can change its setting, of course, as I twiddle the knob, but it doesn't change anything. This pressure here stays the same. In order to set the relief valve, you must deadhead the cylinders in order to force the flow to go through the relief valve. That's the important part, is the flow must go through the relief valve in order for its adjustment to have any effect. So I'm going to fully retract the cylinder using the directional valve. And once it's all the way back, flow ceases Zero flow going in, zero flow coming out, because you can see all the flow is going through the relief valve. There is no flow path up here, so this is the next best place to go. As I adjust this valve now, keep your eye on P1. See what happens to P1 over here? As I change the valve, P1 changes. So I can adjust this to 600 psi full flow, and that's this valve set. As soon as I release this valve back to its neutral position, the pump flow has an easier place to go. Watch what it does. It all goes through the valve neutral and back to tank now. 1 GPM in and 1 GPM out. Okay, now let's run the cylinder back and forth. And notice the flows. While the cylinder is in motion, retracting or extending, notice the flow going into the cylinder through the needle, through the directional valve. It's always full pump flow of 1 GPM. But look at F2. F2 is very strange. F2 has different values. Right now, with the cylinder extending, 1 GPM is going in, but less than 1 GPM is coming out. While the cylinder is retracting, 1 GPM is going in, more than 1 is coming out. That's very strange. The difference is, it has to do with the volume. In order to retract the cylinder, the pump needs to supply a volume to go into the retract chamber. And it's basically a volume that's shaped like a cylinder of oil that's hollow in the center where the piston rod is. So while the flow is going in to fill up this volume, a larger volume, a solid cylinder of oil, so to speak, with no hole in the middle, is coming out at the same time. It's called flow intensification, and it has some implications. Also notice the cylinder extends slowly, but the retract speed is faster, and it's because it needs less volume from the pump to go in here. Say that you needed 1 gallon to fill this cylinder. Wouldn't it take a minute at 1 gallon per minute to retract it? But the volume on the other side would be larger, maybe 2 gallons coming out at that same time. That's why this flow out of the cylinder and back to tank varies. It's not the same as the flow in while the cylinder is in motion. Now, this system, we made a modification. We used to have the line go from A to the retract port, but we've taken that hose off and put it down here through a T connected right to the pump. A little hard to see what's going on in this circuit now. Notice the A port of the directional valve doesn't go anywhere. Only the B port goes to the extend chamber. In the neutral position, we haven't really changed anything. Pump flow comes up. It doesn't go through the relief valve because it's closed. It takes 600 psi to open it. The flow goes up through the flow meter, through the valves, and back to tank. 1 GPM in and 1 GPM out. When the cylinder retracts, look what's going on in the retract position. Well, let me fully extend it first, and let's watch the retraction. Pay attention to the retraction. Pump flow comes in to the retract port, and flow goes out the extend port and back to tank. So even though there's a very strange connection here, the cylinder still retracts the way it did before. Essentially, to retract the cylinder, pump flow goes in here, and this flow coming out goes to tank. But watch what happens in the extend position. Pump flow is connected to both ports. While it's in this position, pump flow wants to come out, it wants to go in to the extend port, but it also is directed into the retract port. You know what we have here? We have basically the same thing that's in this circuit. Pump flow goes to both ports, and there is no connection to tank in this particular case. Look, the tank line doesn't go anywhere. It's a dead end. This is called regeneration. You got to be quick to spot it, but watch what's happening to the flow F1 and F2 while this is extending. More than pump flow is going into the cylinder because it's the pump flow coming in here, but it's augmented by the flow coming out of the retract chamber, which regenerates and joins the pump flow to go to into the extend chamber, and there's no flow back to tank. So during regenerative extension, no flow back to tank, higher than pump flow is going into the extend chamber, and it makes the cylinder extend extra fast. It's useful for a rapid extension when a cylinder needs to freely extend before it contacts a workpiece and starts pushing hard. I hope this helps.